Start in Module 1 by introducing the concepts of cloud computing and by addressing some common IT challenges faced by organizations. In Module 2, we take a journey through VMware's cloud solutions, showing the various components and features and how they can help resolve business and technical challenges. Finally, in Module 3, we wrap things up by helping you relate the products and features to the challenges they are intended to resolve. At the end of this course, you should be able to define the types of cloud computing and discuss the challenges associated with them. Describe VMware's cloud products, features, and components, and align VMware products, features, and components to the elasticity, efficiency, availability, and management challenges of a business. This is Module 1, an introduction to the VMware Cloud. In this module, we will define cloud computing, provide examples of business and technical challenges, and finally, provide an overview of VMware cloud products. At the end of this module, you should be able to define the types of cloud computing and discuss the challenges that VMware cloud products are intended to resolve. Chances are you already use the cloud. You just may not realize it. Cloud computing is ubiquitous, but it goes by so many names that many people don't realize that their day-to-day applications may in fact be cloud-based. Cloud computing just means that you can use an application or system without the need to worry about how the application or system works. It doesn't automatically mean that the application or system is hosted on the Internet. Cloud computing is utilized by organizations of all sizes all across the world. Cloud computing gives your users, developers, and even IT administrators access to shared applications and systems maintained by someone else. In a smaller scale, this isn't all that different from what we do with our data centers today. Your users come into work, turn on their computer, and access systems in your data center. They create data, store documents, and log into systems without ever knowing or caring how the back-end servers are maintained or managed. Cloud computing takes this approach one step further by allowing you to expand the boundaries of your traditional data center to allow your users access to these applications, development platforms, and even dedicated servers on demand wherever and whenever they need. Cloud computing is all about simplicity and ease of management. We group cloud computing into three major service models: Software as a Service, or SaaS, Platform as a Service, or PaaS, and Infrastructure as a Service, or IaaS. Using Software as a Service, your users access shared applications and data over the network or Internet, typically without having to install or configure anything more complex than a web browser. Platform as a Service allows your web developers and programmers the ability to upload their content to pre-configured web servers, database servers, and application servers without having to install or maintain any of the server-side applications or operating systems. And finally, Infrastructure as a Service can give you access to a dedicated virtual or physical workload that you manage and maintain. While SaaS may offer the highest degree of simplicity and ease of deployment, IaaS provides the greatest degree of flexibility, customization, and control. Software as a Service, or SaaS, may be the most widely used form of cloud computing today. But most of its users may not realize they're using cloud resources. SaaS encompasses applications that are used by millions of people around the world. A SaaS offering typically doesn't feel like you're using a server or logging into a system. These applications are designed to look and feel just like the software on your computer. The providers focus on maximum ease of use and simplicity for the end user. SaaS providers such as Zimbra, Gmail, and Salesforce.com are often treated like utility power in the sense that when we open their applications, they just work, often from anywhere in the world. These systems are often taken for granted until they fail, and even then, the users typically aren't overly concerned with how the system actually works. As a user of a SaaS application, you don't need to know how the application works, it just does. There's a catch, though. In order to serve as many different groups of people as possible, SaaS providers typically must keep their applications very uniform and standardized, which means the users tend to sacrifice individual flexibility. Each user won't be able to customize the way the software works, but they may be allowed to customize its look and feel. SaaS offerings must balance the need for flexibility with the general acceptance of the change across all their users. The advantage is that the users aren't required to manage or maintain any aspect of the system, including the backup and recovery of their own data. Platform as a Service, or PaaS, gives you a bit more control because you are given access to upload content to the applications server. This is most commonly found in web hosting providers, but it can also be useful for developers of multi-tier applications that don't require access to the underlying operating system. PaaS providers are able to give you more control, but they typically do not allow full remote control of the underlying server. That means you may be able to develop your application and customize how it operates, but you must still rely on the provider to apply operating system and service patches. This is both good and bad. The good news is that a PaaS environment is generally very stable because any update to the provider's software is typically checked very carefully. The downside is that updates may be slow to come because of the complex dependency checking required of the provider. If you want to take matters into your own hands, you should consider Infrastructure as a Service. Infrastructure as a Service, or IaaS, gives you even more control by providing a complete virtual machine to the end user. This allows you to install services and software based on your specific needs, but more importantly, it affords you complete control over the underlying operating system, including patches and infrastructure configuration, features that are inaccessible in a PaaS or SaaS cloud offering. Due to the exceptional control that IaaS provides administrators, it is ideally suited for organizations with unique compliance or regulatory concerns. And it provides a greater degree of isolation and security between cloud users, because no two organizations share the same virtual machine. There are many forms of IaaS cloud computing, but they share a common trait. The end user is presented with an operating system. The most traditional form of IaaS involves providing a server operating system to a user. There is also Desktop as a Service, or DaaS, that provides end-user computing from a cloud infrastructure. And there is Disaster Recovery as a Service, where physical machines are virtualized in a cloud infrastructure for disaster recovery purposes. IaaS cloud deployments are typically offered in 4 forms: private, community, public, and hybrid. As you've learned, Infrastructure as a Service, or IaaS, gives you the ability to host a virtual machine in the cloud. Now it's time to explain what these IaaS clouds look like and how they work. There are 4 deployment models of IaaS clouds: private, community, hybrid, and public. Remember that we said earlier that a cloud isn't necessarily something on the internet. Many companies have internal private clouds to support the on-demand usage their internal departments require. Some companies have seasonal or burst workload usage, so they look to the hybrid cloud model so they can design their internal data center for normal usage, and then allow the burst usage to run in the cloud. A hybrid cloud leverages both public and private clouds into a single pool of resources. Private and community IaaS clouds give you the ability to provision dedicated virtual machines on demand for your internal consumers. These consumers are typically developers and systems administrators deploying new business solutions for your organization. but they could also be end users of a desktop cloud initiative. As with public and hybrid clouds, private and community clouds give you the ability to monitor and meter your resource usage. This can be very helpful in determining which department is consuming the most resources. But more importantly, this information can be used to help you right-size your private cloud. Private and community clouds build on traditional physical and virtual infrastructure by giving you automation, management, and provisioning tools to quickly deploy new servers and applications. This means that through a self-service portal, you can allow your application owners to deploy and manage their workloads with less IT involvement, without sacrificing corporate policy, standards, or security requirements. The chief advantage of a private cloud environment is control. In a private cloud, your organization typically owns the hardware and manages it in your data center. While private clouds aren't always located at your facility, by definition, the resources are always private or guaranteed to your organization. That means you are in control of who uses the resources, and you are responsible for scaling it up or down to meet your business demands. Community cloud environments are similar to private clouds. However, more than one organization may participate in the cloud infrastructure. Typically, these organizations share a common mission, goal, or security requirement. The cloud hardware may be managed by one or more of these organizations, or it could be outsourced entirely to a third party. The key difference between a private cloud and a community cloud is that private clouds are designed for a single organization, whereas community clouds might be expanded to include multiple organizations with very similar business and technical requirements. But what if you don't want to deal with the scale up and scale down? What if you just want to use the resources without all the management aspects? You might be interested in a public cloud. Through a public cloud, you can provision workloads without the need to manage the underlying infrastructure. The public cloud provider manages your resource consumption and adjusts the back-end infrastructure to meet the demands of their clients. In this way, you can monitor and meter the resource utilization of your clients to provide accurate reporting or pay-as-you-go solutions. You can take advantage of the extra resources provided by the cloud, but you aren't responsible for the long-term ownership and maintenance as you would be in a private cloud environment. Public clouds are designed to host multiple customers simultaneously, and they achieve great success through economies of scale. However, the resources are typically shared by many different customers. Therefore, you need to take appropriate security measures to ensure that confidential data is stored properly in these environments. That could mean using encryption to protect the data, or using a secure VPN connection back to your corporate network. We've been discussing public clouds from the perspective of the consumer, but there are two sides to consider. From the provider's perspective, public clouds allow you to host your clients' workloads in an expandable solution that will allow you to grow the infrastructure as your clients' demands dictate. For example, you can add more computing power or storage resources as needed without disrupting your clients. Hybrid clouds, as the name suggests, are a combination of private and public clouds. They are ideally suited for organizations that can't accurately predict their workloads from one month to the next. A hybrid cloud model leverages your internal data center for your more static workloads, but it gives you the freedom to use a public hosting provider for other workloads. Consider a large shipping and logistics carrier. During the holiday season, its workloads increase exponentially, but they always drop back down following the holiday season. It would be very costly and very inefficient to build its data center to handle the peak workloads when those peaks are only reached once or twice a year. A more economical solution is to build the data center for the normal workloads and then leverage a public cloud provider for the burst workloads. Another use case is testing and development environments. If you have ever needed to upgrade or change your organization's line of business application, you know how many different test and development systems can be required. Even in a smaller organization, this extra capacity may be too much for their data center to handle. By leveraging a hybrid cloud, you can migrate those test and development workloads in and out of your data center as needed without additional capital expenditures. To accomplish this, we have cloud connectors that bridge the gap between the public and private clouds. The connectors can allow you to migrate workloads to and from the public clouds as your resource demands change. We'll talk more about how these connectors work later in this course.